This video demonstrates a simulation-driven organic design of a bridge, starting from a single block of material. I start by picking the template for topology optimization, which will guide me through. I'll leave the default options, and then select this Solid for Bridge geometry. AIM loads the geometry and sets up the topology optimization process with typical default settings. The guided template now asks me to set my design goals. By default, it's set to maximize strength, so we'll start with that. I'll click Finish and let the template execute. Our geometry is a single block of material 20 meters by 4 meters by 4 meters, with some extra edges defined so that I can apply the appropriate loads and constraints. First, I'll click the Mesh task. I'm going to set the resolution to high to optimize our mesh, and then generate it. Next, I'll click the Optimize task. In this task, I can prescribe the limits of mass reduction and define any necessary loads and constraints. I set my optimization options here, under the Physics options. By default, AIM is directed to maintain at least 50% of the mass or volume of the model, but I'm going to increase the percentage to see what the software does. Next, I'll define some loads and constraints. First, I want to ensure the bridge is supported. I'll click the Edge Selection filter and then select these two edges. And I'll define a support constraint. Next, I'll define a remote force from the middle of the bridge. I'll start by selecting all of the faces on the bottom of the bridge. Then, I'll add a force load and set it to remotely apply from an originating point. By default, AIM fixes the originating point at the center of the selected geometry. I want to move that point a little bit up inside. So, I'm going to select the middle edge here and use that to create an originating point location. By default, the point is located at the center of the selected edge. I want to move this point inside the geometry to a distance of 2 meters. Back in the force load, I'll enter a high value. Now, I have this force applying to the entire bridge. I will now solve. As it solves, I can see the output from the transcript. And as the optimization starts, I'll begin to see the solution monitoring quantities. At this point, we are monitoring two things: the stiffness convergence and the mass convergence. Mass converges in the first iteration, but stiffness goes up and then moves down as we converge. Now that the solve is complete, I'll view the Shape task, where I can further refine my shape. Here, I can set how aggressively the shape is adjusted. I can specify the adjustment from aggressive to conservative using the Shape Adjustment slider here. It's currently set to 50%. I can also set the shape adjustment here, in the Graphics window. The output of the optimization is also available once I update. As you can see, this looks like a fairly familiar picture of a bridge. However, this block is losing some material. So I'm going to nudge this to be a bit more conservative and then update. Now everything is connected and I have a full bridge available. I can view the statistics here, which show the original mass and volume and the reduced mass and volume. I can, at this point, export this new model. AIM then creates a new geometry task with this model, which I can then edit for another design iteration. AIM also exports the original model, in case I want to use it as a guide for editing in the embedded AIM modeler. This concludes this demonstration of topology optimization in AIM.